Mercury. Mercury is the closest planet to the Sun and the smallest planet in the solar system. Now, imagine this. You suddenly teleport to the surface of Mercury with no time to prepare. If you appear on the sunlit side of the planet, you would be killed almost instantly by extreme heat. Surface temperatures reach around 430 degrees Celsius. The moment you arrive, exposed skin and eyes would be severely burned, and the body would rapidly overheat beyond survivable limits. Now assume an impossible condition. You are wearing a suit that can withstand any amount of heat. Even then, survival is not possible. Mercury has virtually no atmosphere. When you try to breathe, nothing enters your lungs. Instead, oxygen already dissolved in your blood begins to escape into space due to the lack of atmospheric pressure. Within about 15 seconds, the brain is deprived of oxygen and consciousness is lost. With no external pressure, blood begins to boil, forming gas bubbles in the bloodstream. As this happens, the body swells in some cases, reaching nearly twice its normal size. Cellular structures begin to break down, followed by organ failure. It takes approximately 2 minutes for all vital biological functions to completely stop. Now consider a different location. If you were to appear on the shadowed side of Mercury, where sunlight never reaches, the problem is no longer heat. Surface temperatures drop to around minus 170 degrees. At this temperature, water inside cells freezes and expands, rupturing cell membranes and damaging tissues throughout the body. As body temperature continues to fall, the body becomes rigid and fragile, and even minor physical stress could cause frozen tissue to fracture. Consciousness is lost quickly, but once again it still takes about 2 minutes for all biological activity to fully cease. Compared to what comes next in the solar system, Mercury is almost mild. Venus. Venus is the second planet from the Sun and is often called Earth's twin because of its similar size. But the moment you arrive, that illusion disappears. In less than a second, you are exposed to atmospheric pressure equal to being 900 meters underwater on Earth. That pressure crushes your body from every direction at once. At the same time, the surface temperature of Venus, around 460 degrees Celsius, begins burning through tissues. You are crushed and burned at the same time. Venus's thick atmosphere, made mostly of carbon dioxide, offers no oxygen and no relief. There is no safer location, no shadow, and no moment where survival is possible. To understand just how extreme this environment is, consider this. The Soviet probe Venera 13 once successfully landed on Venus. It was a heavily reinforced metal spacecraft, built specifically for this planet. Even so, Venera 13 stopped transmitting after just 127 minutes. If a machine designed to survive Venus could last only that long, well, the human body would not last even a fraction of a second. Mars. Mars is the fourth planet from the Sun and is often considered the most Earth-like planet in the solar system. But, if a human teleported to Mars without protection, they would lose consciousness within seconds and die shortly after. Mars has a very thin atmosphere made mostly of carbon dioxide, with almost no oxygen. The atmospheric pressure is less than 1% of Earth's, which means the lungs just can't function properly. Within about 15 seconds, the brain is deprived of oxygen and consciousness begins to fade. And, Mars is also extremely cold. Average surface temperatures are around minus 60 degrees Celsius, causing body heat to escape rapidly. Loss of consciousness occurs quietly, without sudden force or violent impact. Even after consciousness is lost, the body doesn't stop immediately. It takes around 1 to 2 minutes for all vital biological functions to fully cease. Jupiter. A human entering Jupiter's environment would be killed almost instantly by radiation, long before any fall or impact occurs. Jupiter is the largest planet in the solar system and is classified as a gas giant, meaning it has no solid surface. It's also surrounded by the most intense radiation belts of any planet. The moment a human appears inside Jupiter's atmosphere, powerful radiation just floods the body. Cells suffer catastrophic DNA damage and the nervous system shuts down almost immediately. Death occurs before gravity even has time to become a factor. Now, let's assume an impossible scenario. The radiation is completely blocked by a perfectly shielded spacesuit. Only then does the next danger begin. With no surface to land on, gravity pulls the body downward into the planet. Winds exceeding 500 kilometers per hour strike from all directions, causing violent, uncontrolled motion. As the descent continues, the atmosphere becomes denser. Pressure rises rapidly, compressing the chest and collapsing the lungs until breathing is no longer possible. Temperatures continue to rise until, honestly, even molecular structures cannot survive. Saturn. If you were to appear near Saturn's equator, you would be torn apart instantly by extreme wind forces, with no time for awareness or reaction. Saturn is a gas giant famous for its rings, but it has no solid surface and an extremely active atmosphere. Near the equator, powerful jet streams dominate the environment. These jet streams reach speeds of up to 1,800 kilometers per hour. The moment you arrive, air currents moving at different speeds and in different directions strike your body simultaneously. The force is not a single impact, it's actually comparable to being constantly struck by the direct blast of explosions from every direction at once. In an instant, every bone in your body shatters under the stress. Organs rupture as pressure overwhelms them and muscle tissue is torn away from the skeleton by opposing forces. The human body just can't endure this level of mechanical strain. Structural failure happens immediately. The nervous system is destroyed before it can register pain or fear. You would not survive even a single second after arrival. Any remaining material is carried deeper into Saturn's atmosphere, where increasing pressure and temperature eliminate what is left. Uranus. Uranus is the seventh planet from the Sun and holds the record for the lowest temperature of any planet in the solar system, reaching about -224 degrees. If a human were to appear inside Uranus's atmosphere, the outcome would be immediate. At -224 degrees, heat is removed from the body instantly. Molecular motion slows so severely that normal biological activity just can't continue. Muscle movement becomes impossible, and the nervous system ceases to function. Consciousness would end immediately as brain activity shuts down. Uranus's atmosphere is made mostly of hydrogen and helium, with traces of methane and hydrogen sulfide. Hydrogen sulfide is the same gas responsible for the smell of farts, giving Uranus its nickname as the fart planet. However, under Uranus's extreme conditions, the lungs would freeze before any sensation could be detected. At great depths, methane is compressed so intensely that carbon atoms separate and crystallize, forming solid diamond particles. Scientists believe that diamonds may fall through Uranus's interior like rain. As pressure and temperature continue to rise, solid matter can no longer retain its original form. Near the planet's interior lies a dense layer of superionic water. Water compressed by extreme pressure existing at thousands of degrees while remaining in a solid-like state. Any remaining material from the body would ultimately be absorbed into this layer, becoming part of the planet itself. Neptune. Neptune is the eighth planet from the Sun and is known for having the strongest winds in the entire solar system. Neptune's winds reach speeds of up to 2,100 km/h, faster than the speed of sound. The moment you appear, these winds strike your body from all directions at once. Skin, muscle, and internal tissues cannot withstand this stress. The body is rapidly torn apart and broken down into fine fragments, effectively reduced to a mist. At the same time, temperatures on Neptune drop to around 220 degrees. Any remaining heat is removed instantly, preventing normal, biological function from continuing.